Hello there, it's your old pal, Mr. Cook, and we're going to do some problems from the textbook. So specifically the ones on page 267, the ones that deal with intervals where it's increasing, decreasing, and constant, and then also finding some specific values on the graph and talking about the domain and the range. Okay. So I'll just start off with problem number 26 from the textbook. I know that we have to do number 25, and they're both pretty similar. So I'm going to go ahead and go through those. So just based off of the graph, it's pretty easy to see where the domain is going to be. So imagine that like the domain is all the possible x values that you could have. And with each x value from the domain, you'd have to have a corresponding coordinate with that same x value on the graph, okay? So like, when we're looking at this graph over here, notice that like I have a coordinate right here located at, it looks like negative 1, 2, 3, 4, and then up 3, so negative 4, 3. And then I have negative 3, 3, so that's another coordinate. And notice that the x values go negative 4 and then negative 3. I have another coordinate over here at negative 2. And another one over here at 0, and then 1, and then 2. And then it looks like I have this arrow pointing off in another direction. So I've got a bunch of other coordinates to go in that same direction. So if you noticed, I don't have any coordinates that line up along the x-axis past negative 4. So that tells me that my domain, the lowest possible x value, because remember that domain has to deal with strictly just the x values, then the farthest to the left that the graph goes on the x-axis is negative 4. It's like the graph stops at the x-axis where it lines up with negative 4. So that means that negative 4 is the lowest possible value that I have. And the graph, if you just follow my finger, it just keeps going and going and going on and on and on forever off of the graph because of that little arrow there. So along the x-axis in the positive direction, it looks like it just keeps going and going and going and going and going. It'll have a corresponding x value from a coordinate, all the way through positive infinity, essentially. So the domain starts at negative 4 along the x-axis, and it just keeps going and going and going forever, in the positive x direction. If you're still struggling with what the domain represents, here's another interpretation of it that might help you out. So imagine that I have, just this graph here, and I've got lights that are shining on it from above, okay? So imagine that I have like a big old floodlights or something like that go for the entire graph, okay? So a floodlight here, and it's shining light down below the graph, and then also I have big floodlights over here that shine, above and below, so lights all the way around. So imagine that you have this graph, this line that's just kind of, it's exactly the thickness of this, this line over here, not thick in any way. And I just had these lights and they were shining over the x-axis. Where would it create a shadow on the x-axis? So like, if this was a wall, the light would shine on it and I'd have a shadow that would start like right over here. And then it would just keep going on and on, because I'd have the light that would be reflected over here against the wall and the light that would reflect over here. So I'd have this shadow that spans the entire x-axis, continually. As long as the graph is there, this light is shining and it has a shadow over here. That shadow represents the domain, so as long as there's a shadow on the graph, that represents the domain of the graph. Similarly, if I were to set up lights, from the side, and as they shine on the graph, what would my shadow look like on the y-axis? Well, it looks like on the y-axis there's nothing past this point, so my shadow would start here, and then if my light was shining over here, then I'd have more of this shadow going onto the y-axis as it goes straight down. So that represents the range. It's all the possible y values that you could potentially get. So if you look at the graph, I have all of the y values possible, below the x-axis, but above the x-axis, it looks like it just stops right over here when y is equal to 3. So that also tells me what my range is. My range has to do with the y values, and the biggest possible y value that I can get from a coordinate on the graph is going to be that 3 right over there, because that's like the top of where the graph goes to. So so for my range, since it's the y values, the biggest possible value that I get is 3 up here, and it goes all the way down to negative infinity for the y values for the range below it. So the lowest value that I get is negative infinity. The highest possible value that I get is that 3 right there. Okay, so that's the domain and the range. Now I'd want to look at the intervals where it's increasing, decreasing, and constant. So if it's increasing, then that means that the graph is going up and to the right. So if I look at the graph over here, it looks like I'm not going up and to the right until I get to right over here. Then it makes this shift upwards and to the right. So when I'm talking about intervals where it's increasing or decreasing, or if it's constant, I'm only mentioning the x values that go along with it, because it's asking you to find the corresponding x values, x intervals, where it's going to be doing all those different changes. So we only have one interval where it's increasing, and since we're only talking about the x values, it's increasing over the x interval from 1 to 2, because it's just increasing between those 2 points right over there. So we just go over to our little table here, and for the increasing values, it starts at when x is equal to 1, and it increases all the way over from to where x is equal to 2. Okay, now for decreasing. So decreasing means that it's going to be going down and to the right, and it looks like the graph is going down and to the right over this region right over here, this interval. So the farthest to the left of that for that decreasing part starts over here when x is equal to -3. It passes through -2, passes through -1, and it continues all the way until it gets to 0 over here. So that's one part where it's decreasing, goes from -3 to 0. All right, and then it's decreasing again, going down to the right over this interval right over here. So starting when x is 2, and it just keeps going and going and going along the x-axis, it'll be decreasing. So that goes on to positive infinity because it goes to the right. So we also start up at 2 and go to positive infinity. And remember, when we have two intervals like this, we join them together with a union like that. Okay, the last part of it is going to be where the graph is constant. So it'll be constant if it doesn't go up or down. It just looks like it's a horizontal line. So I've got two such instances of that on this graph. So for number 26, I have one space where it's constant from here to here. So that starts all the way at -4 and goes to -3. So it's constant from -4 to -3. And then also another place where it's horizontal right over here. It starts when x is 0 and it goes up to where x is 1. So from 0 to 1. And then I just make a little union there, and that connects the two intervals, and I'm done with that part of it. So that's where it's increasing, decreasing, and constant. Increasing from when x is 1 to when x is 2, decreasing from when x is -3 to 0, and also decreasing from 2 to positive infinity along the x-axis. It's constant or flat from -4 to -3, and then also from 0 to 1. Okay, now for the last part of it, where it asks us to find values of f of 0, and then also f of -2, and f of 2. So what this is asking us to do is to find the y value when x is equal to 0. That's what that one asks us. Find the y value when x is equal to -2. And then finally find the y value when x is equal to 2. So we just go onto the graph and find all those values. All right, so when x is equal to 0 on our graph, just look at the coordinates, and it looks like when x is 0, my y value is going to be -1 because of the coordinates. So when x is 0, y is -1. So that means that f of 0 is equal to -1. So there's one of them for us. Now we got to see what happens when, what the y value is going to be when the x value is equal to -2. So we go to the graph, look for the coordinate when x is -2, that's right here. And when x is -2, our y value is going to be a +2. So that means that the f of -2 is equal to +2, and that's our answer for this one. And then we go to the next one, f of 2. So what happens when x is 2? So we look at the coordinate when x is 2, our y value is going to be equal to 1. So there is the rest of it. So that's part D, E, and F of the problem. And this is number 26. All right, that's it.